Alrighty, so how do we find a seasonal index? There's sort of two processes. This is our example data we're going to look at. And these are actually the exact sales, for instance, of, I think it was coats in a business. And they've sold the most in winter, which makes sense. And they've sort of, so more and more coming up to winter and then drop back down in spring. Obviously they're not selling as much. I think actually it was ski gear, coats in ski gear. So they're clearly not selling as much after winter's just finished. There's two things we need to be able to find. We need to find the seasonal index, but to do that we need to have the seasonal average. So just ignore this for now. We'll do the seasonal average first. Basically we want to find out what's the average of all of these four pieces of data. So I might start off with that seasonal average. And you would know by now that to find the average you need to add everything up and divide it by the number of data. And that says that here. Total of all data for seasons divided by the total number of seasons. So let's do that. 920 plus 10, 85, plus 12, 41, plus 4, 46, divided by 4. And here's my answer that I prepared earlier. That was 3692 divided by 4. So my seasonal average is 923. I'll just check that was in frame for you. Not quite. There we go. 923. So the average of all these seasons is 923. That's going to help us find out our seasonal index. Our seasonal index is what we have in comparison to the average. So 920 in comparison to the average is obviously very similar. So we'd be expecting a seasonal index of roughly 1. 1241 is a lot higher than the average. So we'd be expecting a seasonal index above 1, 1.2 or 1.3 or something like that. 446 is way below the seasonal average. So we'd be expecting our seasonal index, which is quite low, maybe 0.5, 0.6, 0.4, something like that. We'll see when we get to it. Let's do our seasonal indexes. So let's go seasonal index. We might start with summer. 920 out of 923. So that's what I'm doing. The actual data for the season divided by the seasonal average. 920 out of 923 is, when we round it off to two decimal places, it's 1.00. So pretty much bang on the seasonal average, which is not surprising. 920 is pretty similar to the seasonal average. Let's go to B, autumn. Now autumn is 1085, that's our actual amount, out of the average 923. And we can see it's going to be more than 1, or higher than the average. And when we put that in our calculator, it's going to tell us 1.18 to two decimal places. So we're 18% above the expected average, or the average for that season. C, winter. If I'm writing too small on these sheets, someone please tell me in class and I'll start writing bigger. Maybe you could just zoom in or something. But please do tell me if I'm writing too small in the videos. 1241 divided by 923. So again, you expect it to be more than the average. And our calculator tells us that's 1.34, so 34% above the average. And then D, our final seasonal index for spring, 446 out of 923. And you'd expect our seasonal index will be way less than 1, quite low. Turns out, in fact, it's 48, 0.48. So that's 48% of the original, which is 52% less than the average. So I took 48% from 100%, 52% less. So our four, I'll just make them really clear for you, our four seasonal indexes are 1.00, 1.18, 1.34, and 0.48. That's our four seasonal indexes. So we could write them in here in a table for seasonal indexes. This was an example for 1 year. Let's do an example for multiple years. Pretty much, I won't lie to you, it's the same process, but we'll just do it over multiple years. So here again is our raw data. We saw this a minute ago, 920, 1085, 1241, 446. But now that was our year 1. We've also got a second year and a third year. We basically need to do it for each, the same process for each of the three columns. So we do for year 1 exactly what we've just done, and we'll get our seasonal indexes. I might quickly put them in for you, our seasonal indexes for that one, because we've already done them. 1.00, 1.18, 1.34, and 0.48. And we're going to do the same process for the rest of them. So I'll quickly just jot down my seasonal averages, because we're going to need them. Seasonal average, and I might go year 1, and we already did the average for year 1, you'll remember, was 923. And the average for year 2 was all of the data added up, so 1035, that's this row here, plus 1180, plus 1356, plus 541, and there's 4 seasons, so divided by 4, and that equaled 1028. So this was my first seasonal average, that was for year 1. This is my second seasonal average, that was for year 2. Let's find our third seasonal average for year 3. I'm going to add up all of them and divide them by 4. We're just finding an average. You know by now that an average is add everything up and divide it by the amount of things that we have. So I've added all 4 of these. I'm going to divide it by 4 pieces of data is what we have. Once I do that, I'm going to get 1183. So that's my seasonal average for year 3. So you can see in year 1 we sold 923, and then we actually increased our average sales in year 2 to 1028, and then again in year 3 we increased our average sales to 1183. So it probably, and we'll have a look at the graph a bit later, but it looks like over a number of years we're increasing our sales, which is always a good thing for a business. So just from this amount of data alone, we can see that our amount is going up over a longer period of time. Our average is increasing, which always just means more money, and which is fantastic for business. So they're going in the right direction. Now that we've got these seasonal averages, let's use them to find out the seasonal indices. So we've done year 1, let's jump straight ahead to year 2. So let's say year 2 summer. So our data for summer in year 2 is 1035. So we'll go, our seasonal index is 1035 divided by the seasonal average for year 2, which is 1028. And again, you can see that's just a little bit above the average there. And when you put it in your calculator, it'll tell you 1.01. So 1.01 is our seasonal index. Let's find out our seasonal index for autumn of year 2. So autumn of year 2, 1180. And the average for year 2, our seasonal average, was 1028. And again, 1180 divided by 1028, 1.12. Which makes sense because we're more than the average. Just put them in boxes for us. 1.12. Let's keep doing that. See, winter. If you're getting the hang of it, now it's probably a good time to skip ahead to the end of the video. I'm going to be doing much a similar thing for the next few minutes. 1356 divided by 1028. And again, you would expect it to be more than the seasonal average, because 1356 is more, so the index should be more than 1 point something. Let's check that, 1.32. And finally, let's not neglect spring. 541 is spring in year 2, so we're trying to find spring in year 2. 541 out of the seasonal average, 1028. So I'm just using those formulas I showed you on the last page. And that equals 0.53. Which again makes sense, because this is much less than the seasonal average. It's almost 50% of that. It all seems to make logical sense in terms of what we expect to get for our answers. And I'm just going to flip over to the next page and do the rest of them. Again, if you're getting the hang of it now, you might want to just quickly fast forward the video and watch that go in double speed. So let's go on to our year 3. I might just record we're on year 3 now. And I might just jot down at the top of our page so you can remember. The seasonal average for year 3 was 1183. So I got that from this page. My seasonal average was 1183. So for summer in year 3, we had summer in year 3, we actually sold 1,299 ski jackets, and the seasonal average was 1183. So our seasonal index for summer in year 3 was 1.10. So I'll put that in my table. 1.10. So let's do the same thing. Let's find the seasonal index for autumn of year 3, and we're looking at 1324. Autumn was 1,324 coat sales out of 1,183. That was our average for the season. And that was 1.12. I'll put that in there. So you can see actually in autumn they've reduced their sales over a longer period of time, which is probably not a good thing. And even in winter it looks like they're reducing, but they're increasing their sales in spring and increasing their sales in summer. That's the kind of analysis we can start to do once we've got this data. So let's go with winter. Winter, not winder. So our winter in year 3 we sold 1,450 jackets. It's not surprising, selling the most ski jackets in winter out of the average of 1,183. So more than the average, and our seasonal index was 1.23 for that. Let me put it in our calculator. And finally, I'll just put that in our table, 1.23. And again, winter, they've actually decreased again, so their winter sales are probably not doing as well. They probably need to fix up their marketing or their sales strategies in winter. Finally, spring of year 3, the actual sales was 659, the seasonal average was 1183, and the seasonal index was 0.56. And no surprise, in spring, straight after winter, you're not selling nearly as many ski jackets. Everyone's finished skiing. Obviously they'll be running sales to pump up their sales, but even so, they've still only sold 56% of the average. And I'll just pop that in our table, last but not least. 0.56. So you can see that slowly in spring they've increased their sales over a number of years. They've reduced them in winter, they've reduced them in autumn, and they've increased them in summer. So this spring-summer time of year for them is actually where their business is improving the most over a period of time. They're still not selling the most, but it's improving the most over a period of time. Whereas in autumn and winter, it's being reduced, so they're probably not doing as good a job at their sales in autumn and winter. I'm going to finish the video there. That's it for seasonal indices. Now we're going to go over the opposite, which is deseasonalising. How does that affect our predictions?